Work. Yes, it worked. Pink. Okay. What I'm going to cover today. Some of you guys are going to be gone tomorrow, right? Speech debate. Okay. I'm going to be covering what is usually called the reverse chain rule and also U substitution. Okay, so it's two little techniques. So number 20 is the first kind of problem that has this. Tomorrow will be a work day. Okay.
I love her cake.
So.
Oh, what the?
Oh, there she is. I'm gonna correct my attendance before I get dabbed upon. Library. There are books there. Books. Imagine reading a book. Imagine reading a book. All right. So listen up here.
He's gonna teach us. I was obsessed with those.
Not yet, not yet. The first thing is the reverse chain rule. So I'm going to show you a quick example, and then we're going to see how I'm going to show you. It's going to seem more complicated than like the first couple on there, but there's a reason I want to show it to you. So let's see. What's the derivative? Let's say I had something like.
I'm sorry, I was trying to get it right, but then it just completely backfired. We're fine.
We're good. We're good. Okay. So let's say you were taking the derivative of this expression. All right.
Yeah.
The answer would be, now remember, this is basically an example of u to the 9th power is going to turn into u prime times 9u to the 8th. Does everyone feel okay about that? So it's the exact same thing. What's the derivative of x to the 9th? Oh, 9x to the 8th. Well, what if instead of an x, it's some function of x? So it's okay, you just tack on a u prime. That is called the chain rule. Okay, so the answer to this one would be 3x squared times 9 times x cubed plus 5 to the 8th. You feel okay about that? Okay. Question?
So it's kind of easy to do that.
Right. So this is something. It's fair warning. This confuses people every single year. Okay. It most likely will be confusing the first time you see it.
You won't confuse me.
What, Jesse?
Well, no, nothing. I'm not saying anything. I was just saying, like, confirming that this is just the chain rule. We're not doing the anti-chain rule.
We are. We're going to reverse it. Okay?
No, I know, but like this on the board is not yet.
We're not yet. This is review. This is just a review.
Okay, good.
So-
Because I was like, this looks the same.
Yeah. The review is, this is where people get confused. And it's very interesting to me why it's confusing. Because typically, no one has any problems with u prime magically appearing when you take the derivative, right? So what happens when you take the derivative of u to the 9th? Is everything okay back there? We're good? Okay. When you take the derivative of this, u prime magically appears. So what must happen in the reverse case?
U prime magically disappears.
U prime must be there to begin with, and it's got to disappear. Okay? So when you take the derivative, u prime appears. When you take the antiderivative, u prime has to be there in the first place and then disappear. So the antiderivative of this would be that plus c. So let's look at an integral. The integral would be, okay, the integral of this. Now, by the way, I usually write this 27x squared okay. So if you solve this integral, the way the thought process would go would be you look at that and go, well, I can see this is my u, and there's almost a u prime there. And so what you would do, you say, well, I know that 27 is, does that make sense? 3 times 9.
Mhm.
So you'd say, oh, there's the u prime that I need. And so you'd say, great, I've got u prime times u to the 8th. And so the answer would be u to the 9th divided by 9. And the dividing by 9 would cancel out that 9. And the answer would be, not surprisingly, because I just showed you where it came from. Okay. You were most likely confused. If not, then great. I guess you're ahead of the curve if you're not confused. So just to recap, when you take the derivative of u to the 9th, you get 9u to the 8th times u prime. That u prime magically appears. Okay, the magic of the chain rule. Okay, and in the reverse case, you need the u prime to be there in order for it to work, and then the u prime will disappear when you take the derivative. Take the antiderivative, sorry. So generally, if you want to make a formula, it looks something like this. It says if you have, now I want to actually show the similarity here. So if you have ax to the n, right, the integral was ax to the n plus 1 divided by n plus 1, right? Plus your constant. Cool beans?
Yeah.
Just a little bit of review there. This says if you have instead u to the n, notice it's still a dx. If you have u to the n, you need a u prime to be there. If you don't have a u prime there, you're probably in rough shape. There's sometimes to create a u prime, there's a couple of options, but through examples we'll show. Sometimes there's nothing you can do. Like if there's no x squared out here, you're not going to get the u prime there. It's not going to happen. So anyway,
What's the u prime is just a constant?
right, that's the time where you'll be okay. So if the u prime just needs to be like a number, I'll show you what to do in that case. You can kind of just put the number there and then balance it out on both sides of the integral. Okay, so anyway, what's going to happen? So this u prime needs to be there. What happens to him when the antiderivative takes place? He disappears. You see the similarity?
Yes.
I guess I could put an a in there too if I want like a constant, right? Yes.
Is it disappearing or dividing by?
Disappearing, I would say. Well, I mean, technically there's no
Technical.
mathematical thing called disappearing, but
I mean, yeah, but when you're writing it, so say your second part didn't have that 3x squared, right?
yeah, say you're trying to integrate just this,
Yeah.
you're gonna have a bad day. You're gonna have to expand that to the 8th power using a binomial expansion to integrate each term would suck. Would be miserable.
Why? Because it's just multiplied by 3x squared, so wouldn't to get back to that you just have to divide by 3x squared? Because then it would have canceled out.
No, you got to be careful when what you're talking about. Well, I'm going to show you some examples here where you can multiply and divide by constants pretty nicely, as much as you want. It's not a good time for that. Just pay attention. But you can't, like, I'll show you an example or two where you can't just go, I'm going to multiply by x and divide by x. We're getting a little ahead of ourselves here, sorry. So let me just get some examples on the board. Does everyone understand this connection here?
Yeah.
Mm-hmm.
And let me just get rid of the a here. If the a is confusing you, this is the simplified version. Remember, a is just a constant. So yes, you can multiply by a constant. It works the same. But so x to the n turns into x to the n plus 1 over n plus 1. Great. That's the antiderivative rule. Same thing happens if it's u to the n, but you just need this u prime there. And his job, his purpose, is to disappear. Okay? He needs to be there to disappear. Again, that's nothing that crazy if you've already accepted this is true. Because u prime appears when you take the derivative. So therefore, he must disappear when you take the antiderivative. Let's do a few examples. Okay. 20a. You've got x plus 2 to the 6th power. So what's u?
X plus 2.
This guy. That's your u. Now, do we have a u prime there? Who's ready to give his life?
Yes, you do.
Yeah. What's u prime?
1.
1.
Ready
And one's
to
there already
give his
implicitly.
life.
Yeah.
Beautiful.
So do you see, this is in the form, I should rewrite the rule. The rule is, again, if you have u prime times u to the n, you can do this. If you're super confused, just for now, use the Richard Feynman. Just shut up and calculate, right? Just there you go. If you can put it in that form, you're good. You can use the rule. So, okay, it's in that form, so therefore I can go, this equals done.
Oh, that's.
Do you see?
Yeah.
Now this one was pretty fortunate, right? U prime was already there. If U prime's already there for you, then you're like, okay, you've made my life pretty easy. Let's look at B though. B is a little bit different. This I think will be sort of close to what Rafe was kind of touching on here, which is okay. So now you got this. What's my U? It's 3x minus 1. So what's U prime?
1. No, it's 3.
It's 3, right?
3.
Yes,
Yes.
yes.
Correct.
It's 3.
Oh,
It's just because of the x. Oh. Yeah, if U is 3x minus 1, the derivative of that is 3. Right? So we really wish that there was a 3 there, don't we?
Yeah.
This one's for you, Jesse. We will make it so.
Beautiful,
manifest.
beautiful. That was,
Oh, whoa.
okay.
So what have I technically done there? I've multiplied the
What did I
I've multiplied it by 3. Am I allowed to do that? No.
Wrong.
But I can multiply it by 1, which I've just done. So this is highly analogous to when you're manipulating a fraction and so say you're trying to add 3/10 with 2/5 and you say, oh, I'm just going to multiply this guy by 2/2. It's highly analogous to that. You can take a term and multiply it by 2 and then divide by 2 and you haven't changed the value of the term, right? So like with everything in calculus, you can always connect it back to baby math, right? Like this. It looks confusing, but really you're just saying I'm not changing this thing's value by multiplying by 3 and dividing by 3. Now the thing you gotta be careful with is the way integrals work, the integral of say 5 times x squared is the same as 5 times the integral of x squared, right? That's a big idea that
Yes.
that you have to understand that makes this legal. So Rafe, I think what you were talking about is what you can't do if you have an integral of x times x squared, you cannot be like, oh, I'll just do this. That does not work. So you can think of it as like constants can kind of go in and out from the integral.
No, it'd be the same as the integral of x times the integral of x squared, right?
This?
Yeah.
I'm saying this is not.
I know, I'm saying that's not.
Yeah.
That would be equal to the integral of x times the integral of x squared.
No.
Can we just solve the problem?
This one?
Wait, hold on, no, I have a question. So why can you move the 5? Like, or why, because it's, like, just, what's the mathematical reason for that?
Well, hold on. So Lillian, the answer is just 1/3 times that to the 6th over 6. So you
That's
just
the
follow that
answer?
rule. Yeah.
That's
So
what I
the,
thought.
Right.
And then you just.
You're right.
so the rule is, so the 1/3's out there. You've got your u prime times u to the 5th. So you'd go 1/3 times u to the 6th over 6. And then you'd simplify that as 1/18.
Yeah,
Okay, so there you go. There's the answer. If we're still stuck in the answer. So that's a good question as far as why does this work with constants?
yeah,
to really get a good answer to that question, you have, I mean, that's an extremely deep question, but, yes. But it has to do with the fact that, you know, we take derivatives, like, it all comes back to this. Like, the derivative of, say, 5 times x to the 4th is the same as 5 times the derivative of x to the 4th.
Okay.
Now, again, that raises further questions. Why is that true to begin
Yeah.
with? But, I mean, you can talk about what multiplying a function by 5 does to its slopes, and you can actually prove this is true with the limit definition of the derivative. So if you want to get really rigorous, you can prove that's true from the limit definition. And then the reversal is, then you reverse it with integrals.
Yeah.
And you can show that it's true. And then if you really want, you can make a rigorous definition of what an integral is, and then prove it.
Okay.
So that's kind of outside the bounds of a
So why can't you just reverse the chain rule?
That's what you're doing.
Like we're doing with the other one though. So not with a constant, but if u prime is some other equation
Right,
and you multiplied it to get there, why can't you divide it back to get back?
right. So that's because, okay, so back to the derivatives. The derivative of, say, x squared times x cubed is not the same thing as the derivative of x squared times the derivative of x cubed, right? So therefore, so let me show you a really concrete example here, okay? So what's very tempting for people to do is, let's say you had integral of x squared plus 3 to the 5th power, okay? Obviously, it's tempting to go like this, right?
Yeah.
That, you cannot do that. That would be a violation. That would imply that I can just multiply x's inside and outside of a derivative. Well, if that were true, then the thing I just erased would also be.
Okay.
Does that make sense?
Paul,
I think so.
for that, then the correct way would just be to take out the x's then, right? You just have to
Oh, I
take
think
one.
it did.
No, this,
No.
so if you have this, there is not much you can do. The only way you can really integrate that is to expand this with the binomial expansion.
Okay.
To the 5th power.
Yeah, you'd have, I mean, it'd be a mess. You'd have
Yeah, but-
x to the 10th plus 15, x to the 8th. There'd be 6 terms in there, and then you just integrate them
Okay,
separately.
well,
Oh, he
that's-
disappeared, that's right, he
So
disappeared.
that is the derivative of something.
This is, yeah.
Yes. Okay, and so to find the previous that, it would have been u prime times the u, it would have used the chain rule to find it.
If some function, so imagine there was some function of u, here's the problem, is if you're thinking, well, there must have been some like u to the 6th power type thing that produced this as its derivative, well, there would have been a u prime. There would have been a u prime there, but there's not, so.
Unless it was already divided by its own u prime,
Or,
right?
but then you'd be using the quotient rule.
Yeah.
So like, suppose you had, I'm glad to talk to you about this more, but we're kind of like,
Okay.
at this point, we gotta do some more examples, but, for now, just,
Gerald, can I just solidify something with you?
yeah.
Because we've gone in circles here. But hold on. So it only works is if the u turns into a whole number without any x's or anything on it, and then that works. Or it's 1, basically. Is that kind of how you're going about it? Because every single time it hasn't worked is when it's been like 3x squared.
We gotta do more examples.
Ah.
So the rule of Ave is this: if you have any function that lives inside here,
Okay.
you can multiply by a constant and divide by that constant.
Okay.
As long as that's a constant, that is 100% legal. But you can, that thing you're multiplying by cannot have any x's in it.
Okay, that's
a
what I was
simple-
going
yeah,
for.
That's
That's
I'm
what I
gonna
was
say the rule.
going
The rule is you can multiply and divide by any number you want. You cannot multiply by x and then divide by x. That would be illegal. Okay.
Clear.
Now, Rafe was asking really about getting into why, I think, which like is a great question, but I don't want to eat up all class time with like.
Really interesting.
It's a rigorous question, but it's tough to answer. It's not something I can easily just give you the answer to. It probably would require a lot of like.
I'm planning to go into this, so hopefully I'll learn this later.
I'll
To each their own.
I would love to discuss with you.
Okay.
I'm more than happy to
Yeah,
talk
no,
about.
I just, okay.
But we could talk for a whole week about it and then, okay, so C, what's my U?
It's.
U, what's U prime?
Oh.
1/2.
Yeah. Yeah.
You get that?
Yeah.
Don't forget, x divided by 2 is the same as 1/2 times x. So what's all I gotta do? Who do I want to live here?
1/2.
I want to put a 1/2 there. So what do I have to put out here to balance them out?
2.
Boom. Okay, so now, do I have u prime times u to the 4th? Yes, I do. Don't forget about that 2 that's out there though. So I have 2 times, now let's deal with this goop gob here. Okay, so what you end up with here is u to the 5th over 5. Now you're probably gonna write your final answer like 2/5 u to the 5th.
Let me wrap my head around
2
this for
divided
a
by
second
5.
here.
Oh,
Just
sorry.
rewrote it. Seems a little bit nicer to write like that.
Okay.
I'm confused. Where did the two? Wait, the two from the outside is what's this?
Do from the outside.
Well, just so 2 times banana over divided by 5 is the same as 2 divided by 5
No,
times
the 1/2
banana.
was on the inside.
We made it go poop.
He lived his life purpose. His life purpose is to disappear.
We delete them.
We have fulfilled his purpose
He has
in life.
become poop
Can I
toad.
get some of that?
Oh my god.
Okay. Don't worry, guys. I'm doing it. It'll click at some point through doing a few examples. I promise it will. Okay. This one.
Yes.
What's the U?
3/5 x minus 2.
This guy. So it would be awfully nice if right there lived what number?
3/5.
3/5, which means I need to put
5/3.
5/3 out here. Now this is the tricky part for people to understand is this now, this thing I'm putting the box around, circle or whatever, that is that. That is u prime times u to the 9th. So this guy in the dotted circle becomes u to the 10th over 10. But don't forget, there's still a 5/3 there. Right?
Yes.
So my actual final answer then, are we okay with going from here to here, everyone?
Give me a second, then it will be. Yes.
Okay, so then 5/3 divided by 10 would be a 1/6. So my answer to this is actually 1/6 times u to the 10th plus a constant. There's your answer. Yeah?
Yeah,
Okay.
your dotted line, is very good. You're not quite, what's his name?
Walter Lewin.
Yeah, Walter Lewis.
Turned out he was disgraced, actually.
Oh, yeah, but we can still
Well,
appreciate
now.
his lines.
Yeah, I know, it's sad though.
Well, I mean, everyone is kind of awful.
Not like that guy.
That's true.
What do you?
Bunch of Me Too type stuff.
Not good, not good.
Sad, I know, it's terrible.
But his lines were nice.
Yeah, apparently he was like doing a lot of harassment and stuff, so. Yeah,
Like,
no more, now I can't watch his tappy tap lines the same way. Okay,
Same way.
Tabby.
The same way. Oh, boy.
Okay, E. All right.
Yes, we do know. We know this.
How do we feel so far? Make sense, sort of? Is it starting to make more sense?
Yes.
This one looks more intimidating, but it's actually not. Here's why. What's my U?
That one.
That thing. So what is U prime?
Prime is
12x cubed. So what I breathed a sigh of relief because I've got the x cubed. That's the important part. So the only reason he's not exactly where I want him to be is I just wish that was a 12.
It's a 12x cubed, not squared. I looked at the.
Hold on.
Yeah, so this is my U, so the U prime I'm looking for would be 12x cubed, right? Did I say 12x squared?
Yes.
Okay, sorry, I misspoke then, yeah. 12x cubed. Now I say, oh, you are awfully close to being a 12x cubed. And the key difference is, the only difference between him and the u prime that I want is a factor of 2, right? So what do I have to put out here?
One half.
Half.
Oh.
And you can check your process really easily. Is 1/2 times 12x cubed 6x cubed? Yeah, so I didn't change this. I didn't change the integrand.
That's a word.
Yeah, this thing's called the integrand. The tasty nougat inside the integral is the integrand.
The tasty nougat.
Okay, prepare yourself. You ready? Don't get confused. What is his purpose in life?
Disappear.
His purpose in life is to now go poof. You go bye-bye. So now the answer is going to be, this 1/2 is chilling out here, and this inside is going to become u to the 6th divided by 6.
Oh.
And so my answer is 1/12 times 3x to the 4th minus 8 to the 5th. Okay? What did I miss?
Don't worry about me. I got it, Jesse, and I was celebrating.
Oh, thank you, the 6th, thank you. The 6th. Testing you, just testing you. We keep going? I don't know what time class ends today.
Can we do after?
I'm assuming it's delayed.
Interesting. Well, I guess you
Can you just make it
Nope.
look like that?
What?
I'm talking to myself half and then kind of
Let
talking
me
to
see
you.
what time class ends. Thank you, Aspentoe. I appreciate you. Okay, let's do F.
Can you make it just?
We're gonna keep going. We're just gonna keep doing examples to the end of class, and hopefully it'll click for everyone. Okay. You've got x minus 3 to the 1/2 power.
Can't.
There's our u. What's u prime?
1.
He's already there. That's nice. We like that. That makes us happy.
Mm-hmm.
So the answer to this would be u to the 3/2 power divided by 3/2, which of course it makes a lot more sense, right, as 2/3. That's pretty painless, right?
Yeah.
Not too bad.
Yeah.
By the way, there's a whole thing. You might be thinking something like, so you're saying if your u is just like a linear term, like just an x plus or minus something, that it's effectively the exact same thing. And that has something that, you can think about that in terms of like, that's just a shifted square root. So the integral is just a shifted version of the integral of the square root. Anyway, let's move on. Let's look at mean number. LeBron James.
9 plus 10 number.
9 plus 10. That was a good knee maze. Remember that time where he said LeBron James?
Oh, that was hilarious.
That was pretty good.
That was epic.
Okay. So don't be scared of 21A. Don't be scared. It might help you to rewrite that parenthetical as 1/3 x minus 1/6. Right? That maybe looks a little bit more
Friendly?
friendly, yes. So you're like, oh, okay, it's just linear. It looked like a big old fraction at first, but it's actually just a linear thingy. Who do I wish lived here?
1/3.
1/3. So who has to go out here?
3.
3. Now this 3 is still here.
Ooh.
Okay, now this guy is my u prime u to the 5th. So I'm going to be basically having u to the 6th over 6, which means this factor is actually 1/2.
Oh, it's starting to click.
Is it now?
So what you're going to find on these, if you haven't noticed already, is the number that kind of ends up out here often is not obvious, right? It turns out here, this 1/2 came from the 6 that got created by the exponent, but also the fact that this 3 is the reciprocal of that. So it's not a very obvious line to get to this number here, okay? B.
Mm-hmm.
Have you ever realized that the letter B is like a homonym with the animal called a bee?
Oh boy.
Only geniuses can understand.
Alrighty, okay. Okay.
Okay.
Said it, just made it that much better.
Are we ready, spaghetti?
The 1/2.
Just testing it. Just testing it. Okay.
Testy Westy.
We're gonna do this one, then one more, and that should hopefully be enough. Who do I want him to be? Yeah, I'm like, yes, he's an X, because I need him to be of that order, okay? But I wish you to be a 10X. Which means I just multiplied the integrand by 10, so I need to multiply the integral by 1/10. So now this, what I have written, is identical to what was originally written, the original problem. So now I have 1/10, and this is going to end up being u to the 3/2 divided by 3/2. So you have to multiply 2/3, by 1/10, which is going to give us 1/15.
Big brain.
So my answer is 1/15 times 5x squared plus 1
Yeah.
to the 3/2.
Let's see.
Plus constant.
So on that one,
Yeah.
the reason it works is because the X was already out there.
Correct.
But if the X wasn't there, then it would
Yeah,
work.
that's here. This is a great one to check on the computer. Which is-
Where did the 10 come from? That's what I'm.
The
Me.
derivative of 5x squared.
What do you mean? Why did I put a 10?
Yeah.
Because this is u, so u
Oh, yeah.
is 5x squared plus 1. So I wanted to have a 10x.
Yeah.
And the only thing I have the power to do is to multiply and divide by 10.
Oh, yeah.
Dang, so, oh, it's doing pretty good.
Yeah, it's doing better than it was.
It's still down.
Okay. So watch this. Taking bets. What if? All right, listen up. This is good info here. What if the problem did not have the x outside? Because this is a pretty easy question. Like we're just a couple days into doing integrals, and that integral is something we can do. So that means it's obviously not a super challenging integral. Okay. Let's see. What would the answer have been if there was no x? Oh, great machine! What is the integral of the square root of 5x squared plus 1? So it's 1/10 times 5 times the square root of 5x squared plus 1 times x plus the square root of 5 times the inverse hyperbolic sine of the square root of 5 times x plus a constant. So as you can see,
Well then.
what?
Yes, clearly.
Yeah.
So you can see this got bigly more complicated when you don't, if that u prime is not there to cooperate with the process, that is
No
a much,
fun.
much more complicated. We're not going to talk about hyperbolic sines at all.
Oh, thank God.
That's a change.
Okay,
Sounds
but
like
I
a
want
great
to
little
know
challenge.
what it is. I want to know what that is. Not today,
Well,
though.
I'll show you this one, Jess. Here. Here's an interesting one. The
Okay.
integral, you remember who this is, right? One of my best, Mr. Humpty Dumpty. It turns out the integral of Mr. Humpty Dumpty is the inverse tangent function. Isn't that pretty lit savage?
Oh,
That's
Pretty weird, right? That's what we'll learn in this class. We'll explain why that's the case.
cool.
We'll prove it rigorously. We're going to prove that one rigorously. Okay, last question, last example. Let's do one with a big old fractione.
Looks like C to me.
C? Or
Okay.
E, because that one has to the 7th, and that's a lot more scary.
Okay, we'll do E instead, sure.
Woo!
Hopefully you'll see, Ave, that it's actually not more scary. They're equally,
They're
they're
equally scary.
So E looks like this. You've got an integral of 5 times 2x plus 1 to the negative 7th power. Okay, so what do I want this number to be? I wish he was a 2. So what you do is you say, I'm going to make you a 2. And then just, you got to think what has to be up here in order for this to be the same as what we had before. 5 halves.
Oh.
Do you all agree that 5 halves times 2 makes 5? Okay, so
Yes.
good. We've got it.
Five disappeared.
Well, it doesn't just, well, really what I did is you could say I moved it outside. You can think about it however you want. I mean, I tend to think about it like I'm moving 5 outside,
Sacrifice.
then multiplying by 2, and then dividing by 2. But some people just go, they think I changed the 5 into a 2, and then just figure out what number does this have to be
Yeah.
to balance the books effectively.
Or the sticker of divided 5 by 5.
Sure, yeah, there's different ways you can think about how, all that really matters as long as like you understand that what you end up with, this has to be u prime, and this has to be a number that makes this times this gives you the original number. So anyway, the 5 halves is chilling. This is going to turn into u to the negative 6 divided by negative 6, which means my actual answer is negative 5/12
What? No.
times 2x plus 1 to the negative 6. And then I guess while we're at it, this would typically be written, this is good practice of our exponent properties, this would typically get written as negative 5 over 12 times 2x plus 1 to the 6th. This is your standard, this is the way I write that, it's typical. Okay? Not too bad, right guys? It's not too bad. It's not too bad.
Yeah.
What did he say? Was it a pun?
I said, you think we're above standard, right?
Oh, you're above standard, yeah.
Yeah.
All right. Let's see how GameStop's doing.